Okay, we talk about volume as in cubes, right? How many cubes can I fit in a place in a figure, in a solid? Now, in the metric system, we have the measurement called liters. Liters is to measure liquid. Now, the way we're going to measure this volume, the volume is the space an object occupies. So in question number 21, for example, I'm looking at how big is the key? How much space is the key measured? Now, two shapes that I'm giving you here. One, I'm giving you this container of water with the key outside. And I see my water gets to 50 milliliters, right? This thing's going to be milliliters. You guys see the measurement milliliters. So just the water itself is 50 milliliters. In the second shape, it's the water with the key in it. And I see it got to 60 milliliters. So again, just the water itself was 50 milliliters. I put the key in there and it rose to 60. 60 milliliters is the water plus the key. The way I'm going to find out how much space is the key occupied, I'm going to subtract those two numbers. 60 minus 50 happens to give me 10 milliliters. Now looking at question number 22. I have a container of water and it looks like a U shape because it's a cylinder shape. So I see this is 10. This is 5. So I'm going to say 6, 7. So it gets to 8. My water, I'm measuring this low point. It gets to 8. It looks like a low point, but it's really because of the shape that we're looking at it, looking from the side. So just the water itself is 8 milliliters. If you want me to, I'll write it down here at the bottom. Just the water is 8 milliliters. Now the water with the orange in there, right? This is 10, this is 11, this is 12, 13, 14, and obviously you see 15. My water level is there at 12. We want to, I'll measure it here, 12 milliliters. So 8 is just the water, 12 is my orange with the water. For me to find out how much water is just my orange, I'm going to subtract those two values, 12 minus 8, and I'm going to say this is 4 milliliters. As a matter of fact, my instructions said find the volume in milliliters. So I don't have to type in the measurement because I already said it was going to be in milliliters. So it is nice. And then I'm going to say scientists, when they're doing experiments, this is how they calculate volume. They throw things in there. But now at home, what can we do at home? We can, let's say we have a fish tank. And now in this case, you notice how on the left, I just have a regular fish tank, just a fish in there. But on the figure on the right, I have the fish tank, the water went up a little. And then there's the shoe in there. I want to know how much, what's the volume of my shoe. So, but in this case, I'm doing cubic inches. Okay, so let me get my measurements first. My figure on the left, right now it looks a little blurry, but on your screen, when you do your homework, it should look better. I'm gonna say this measurement at the bottom is gonna be 5 inches. I'm gonna use that ruler given. So it's gonna be 5 inches. This measurement at the side is going to be 3 inches. And in my case, this height right here is going to be 9 inches. So that's the water, that's the fish tank with water, fishes, and everything without the shoe. And then with the shoe, I see the measurement here at the base is a 5x3 base, which it doesn't change. It's a 5x3 base. But now the height using the calculator, I'm going to find out is 12 inches. So the height changed. If I was to compare just the difference, I'm going to do, the way I'm going to find out how much is the volume, I remember the area of a prism is area of the base times the height. The base we see is a 5 by 3 rectangle. So I'm gonna say it's gonna be 15. The base is 5 by 3, so 15. Now the height is because I added the shoe. I'm not gonna look at the height of the water with the shoe and everything included. I'm gonna look at how much did it change. Okay. How much did my height of the water change? It was 9 inches and now it's 12 inches. So the difference of the height is 3, right? Notice how the base is a 5 by 3. The base did not change. So the area of the base times how much of my water changed from 9 went to 12, so 3. Okay, so 15 times 3, my answer in this case will be 45 cubic inches. I'm measuring the change of the water, the change of the levels, how much did it change? Number 24 looks like a cylinder. Okay, there's a cylinder, it has water in it. Notice how my radius is the same cylinder. The radius is 0.5 inches. Now, the height of the water by itself to begin with was 2 inches. Now, the water with the rock increased to 7.4. So what I'm going to do, I remember the area of a cylinder here is area of the base times the height. Now, the base is a circle. The radius is 0.5. So 0.5 squared times pi, right? Radius squared pi. That's how we do the area of a circle. The height is not the height of just the water or the height with water in the rock. I'm looking at the difference on the height. How much height did the rock add? It used to be 2 inches. Now it's 7.4. So I'm going to say the rock added 5.4 inches. Right, I'm going to subtract those two out. Okay, so let me multiply this out. 0.5 times 0.5 times 3.14 times 5.4 is going to give me 4.23. My 3 is too small, so I'm going to say 4.2 cubic inches. Okay, so you guys will play with these. Now, let's move on to density. Now, density is very important. Density is how much of a product is there. If you guys have gone to classrooms and you guys go see a desk, right? The desks are tend to be hard. That is cardboard. Just very, very compressed, but that's cardboard. If I just put a box of cardboard and I ask you to write on it, more than likely you're not going to be able to, right? A cardboard just standing on the just standing up, you're not going to be able to write on it because it's too soft, the cardboard. But if I add many boxes of cardboard and I press them down, it's going to get hard, and that's basically what we see in the classrooms. That is density, how much of an item I added. So here it says Anthony's baking a cake and has mixed 370 mini chocolate chips into the batter. Anthony pours the batter is poured into a rectangular pan that measures 10 inches by 14 inches. After it's poured, the batter measures exactly 2.2 inches in height. What is the density of chocolate chips in the batter? Round your answer to the 2 decimal places as necessary. Cool thing is that on your answer, read these words at the end. Chips per cubic inch. Okay. So I'm just going to think there was a pan that was a 10 by 14. And then the height of this came out to be 2 inches. So when I imagine that, let me do better here. Let's see. I think of a rectangular base. That gets increased. Now my base to begin with was 10 by 14. And then the height of this is 2.2. So the volume of this is 10 by 14 by 2.2. Let me find out what's my volume, because it says how many chips per cubic inch. So let me find the cubic. So let me find the cubic inch. Let me find the volume. So I'm going to go 10 times 14 times 2.2. So the volume of this is 308, right? This cake mix that he has 308 cubic inches. He has, so let me say 308 is the volume of the batter, right, that he's mixing. He has 370 mini chocolate chips. Now here my question is, how many chocolate chips per cubic inch? So I'm just gonna go 370 divided by 308. I'm gonna round my answer to 2 decimal places. So I'm gonna write 1.20. Now, you guys will be, why 2 decimal places? Because that's what it says on the instructions. Round your answer to 2 decimal places as necessary. Okay, not bad. Here, number 26. A city limits form a perfect circle that has a diameter of 10 miles. So let me imagine a city. It has a shape of a circle. Let's say that's a circle that has a radius of 10 miles. The city has a population density of 450 people per square mile. What is the city's population? Okay, so let me find out first. Oh, my diameter is 10 miles, right? So actually my radius is 5. The diameter is 10 miles, so the radius is 5. I can find out what's the area of this circle. I'm just gonna go 5 times 3.14. So I find out that my area of my circle is 78.5. But interesting though is that so 78.5 square miles. That's how big is my circle, the area of my circle. Interesting though, it says my densities, it has 450 people per square mile. I know my area of this city is 78.5 square miles. They have 450 people per square mile. Okay, so what's the population of the city? Let me multiply those out. 70.5 times 450, it's going to give me 35,325. 35,325. Now here, round to the nearest integer. Some of your homework, you guys are going to deal with questions like this. Some of your questions are going to have decimals. Now we cannot have people in decimals, right? We cannot have half of a person. It's either you have the whole person or you don't have a person at all. So when it comes to people, we're going to round it to the nearest whole number. In my case, it came out as a whole number. In your homework, some of them will be decimals, rounded to the nearest whole person. Another question that we have in density is 27. A solution contains 6.7 grams of salt per liter. How many liters of solution will contain 28 grams of salt? And round your answer to 2 decimal places. Okay, so let's take a look. First sentence, solution contains 6.7 grams of salt per 1 liter, right? So I'm just going to say 6.7 grams of salt is equal to 1 liter of liquid. Now, here, when we keep on reading, it says, how many liters of the solution will contain 28 grams? So then I'm going to say, well, 28 grams is equal to X liters because it's saying how many liters. I have no idea. Interesting though is these two equations. Notice I put grams with grams, liters with liters. I'm just gonna make proportion. Two fractions equal each other. The cool thing is that grams and liters, the measurements cancel out. So I'm just gonna cross multiply. 6.7 times x is 6.7x. This is equal to 1 times 28 is 28. To get x by itself, let me divide both sides by 6.7. So according to my calculator, 28 divided by 6.7, it gives me 4 point and a bunch of numbers. Now my instructions said round your answer to 2 decimal places. So let me write down 3 decimal places first. 4.179. I do look at the third decimal place. In this case, it's big enough. So my 9 pushes the 7. So my answer is 4.18 liters. Now let's take a look at number 28. Suppose that you need to pump air into a soccer ball that is completely deflated. The deflated soccer ball weighs 22.33 ounces. So interesting. This is just the ball by itself. After being inflated, the ball weighs 22.68 ounces. Okay, so 22.68 is the ball with the air. Okay, before I continue reading, let me find out how many ounces is this air. All right, 22.68 is the ball with the air. 22.33 was just the ball without air. So I'm gonna say the air is 0.35 ounces. All right, I subtracted my two numbers. So the air is 0.35 ounces. Okay, so I continue reading. The soccer ball has a diameter of 0.82 feet. What is the density of air in the ball? Assume that the ball is perfectly spherical and round your answer to 2 decimal places. Okay, so the ball is a sphere and my diameter is 0.82. So I'm thinking there's a sphere and the radius is half of my diameter. So my radius is going to be 0.41 feet. Okay, I need to know what's the volume of this sphere. But I remembered I gave you guys the formula for the volume of a sphere. I even derived in the previous lesson. Remember 4 times radius cubed pi over 3. So let me remind you, the volume of a sphere was 4 times radius cubed, so radius 3 times pi, and I'm using 3.14 for pi divided by 3. So when I type this in, 4 times 0.41 times 0.41 times 0.41 times 3.14 divided by 3, it gives me like a 0.288549253. So according to my volume, it gives me 0.288549254. And I know this is in cubic feet. Okay. Now I'm going to give you guys a hint on how to do this. Look, I have ounces divided by cubic feet. I know something about ounces. I know something about cubic feet. Let me divide those. 0.35 divided by my volume. Round your answer to 2 decimal places. I'm going to get 1.21. Pretty cool. When it comes to density, there's many examples that I can come up with, but these are the 4 examples I'm going to give you. Okay. Any questions, you know how to contact me.